community, discipline, ambition. Those values have shaped our university since its birth. It is time to bring them to the sky.
This project started from a fun idea, to apply what I've learned and develop the first glider ever produced in the University of RIBEIRO while bridging the current research gap in small, unpowered aircraft. Our goal was to create a practical approach for future engineers entering this growing field, which has applications ranging from recreational uses to terrain surveillance. We knew that the project was very ambitious. To research, develop, simulate and produce a completely new vehicle in the span of one academic year was very difficult. An Herculean task. People told me it was impossible.
We figured that most gliders have a high aspect ratio and also some sort of taper ratio on their wings. And, according to that, we decided to implement that at our wing, obtaining the following characteristics. The simulations were very labor intensive and involved working with 3 different softwares between XFLR5, ANSYS and Siemens NX. From the XFLR5 2D simulations, the major takeaways were that the ST7037 was the highest performer and the E205 were ruled out due to its inconsistency. The ANSYS results were similar to the XFLR5 ones, and the values of the 3D simulations of this last software helped us to choose the ST7037 for the whole wing due to its similar performance and simplest manufacturing. In NX, we proved that the wing is safe to fly under a 4G load, which is double what we expect to see in a real flight, and we analyzed the natural frequencies in order to obtain the flutter velocity, which is about 3 times the operational velocity of our vehicle. The production phase is certainly the most rewarding part of the project. Production of a piece demanded several details such as the spar supports, the longitudinal cut, and the lightning walls that were necessary to create a good part. Even without these details, the initial prototype still came out with defects, and we solved this by introducing some settings in the slicer. Namely, what we changed was the wall loops that we set 1, the top shell layers, the bottom shell layers, and the sparse infill density, which were all set to 0. And with that, we proved that the impossible was, in fact, possible.